Okay, so I'm going to go through part of this somewhat quickly. Right here, I've drawn the characteristics just because I wanted to have something more precise, so I used Desmos to do it. But forget that those are there for now, and we'll talk through them. So t dot is going to be equal to 1, t of 0 is 0. X dot is going to be equal to 0, x of 0 is x naught. Z dot is equal to 0, and z of 0 is either going to be 4 minus x, or 2, depending on what x naught is. Okay, so over here, the initial condition tells me that u of x0 is equal to 4. So if I look at the x naught less than 0 part of the plane, I'm going to have t of s is equal to s, z of s is equal to 4, and x of s is equal to 4s plus x naught. So I know they're going to be lines going the path through the negative x-axis, and their slopes are going to be 1/2 or 1/4. If I look at the blue part for 0 less than x naught less than 2, what's going to happen here is, again, t of s is going to be equal to s, but now z of s is going to be equal to 4 minus x naught, and x of s will then be 4 minus x naught s plus x naught. Okay, and if I come back over here, I know that in this part, u, for a generic point AB, u of AB is going to be equal to 4. If I come over here and try to do the same thing, I'm going to have u of AB is going to be equal to 4 minus x naught. Okay, so now I need to figure out what x naught is. If I look at my equations, I'm going to have b is equal to s. A then is going to be 4 minus x naught s plus x naught, which we can write as, s is equal to b, so this is going to be 4b plus x naught times 1 minus b. And so this gives that x naught is equal to a minus 4b over 1 minus b. So over here in this part of the plane, in the blue characteristics, we're going to have u of AB is equal to a minus 4b over 1 minus b. Okay, and finally for the purple part, I'm going to have, so this is going to be x naught is greater than 2, t of s is equal to s, z of s is equal to 2, x of s is then going to be equal to 2s plus x naught. And so these are going to be the purple characteristics there. They're going to be lines whose slope are 1/2. Let me say a little bit more about the blue part. So the blue part, if I look at the extreme cases, if I look when x naught is equal to 0, x of s is going to be equal to 4s plus x naught. In other words, it's just going to be like the dashed orange line there. On the other extreme case, if x naught is equal to 2, x of s will be 2s plus x naught, so it's going to be that purple characteristic there. And in between, the slopes are going to increase from 1/4, from being a slope of 1/4 to being a slope of 1/2. And they're all going to intersect right here where x is equal to 4 and t is equal to 1. So this is why in the homework I suggested kind of splitting the problem up into 2 pieces. So everything that we've done so far is only valid for t less than or equal to 1, because down there the characteristics don't intersect, so there's no shock wave, there's no expansion wave, anything, nothing like that. And so for t less than or equal to 1, we can write u of xt will be equal to the following. It's going to be equal to 2 in this upper part. So the equation for that dashed line is t is equal to x over 4. So this region is t is greater than or equal to x over 4. So this is going to be x less than or equal to 4t. Okay, for the purple part, it's going to be equal to 4 here, not 2. It's going to be equal to 4 here. And it's going to be equal to 2 in the purple part. And then this purple line has equation x is equal to 2t plus x naught, or sorry, 2t plus 2, and so that's going to be x greater than or equal to 2t plus 2, and for the blue part, it's going to be x minus 4t over 1 minus t, and this is going to be for the rest of this. So 4t less than or equal to x less than or equal to 2t plus 2. Okay, now I want to sketch some solution profiles for different values of t to show you what's going to happen when t is equal to 1. So if t is equal to 0, so if I first look to see what happens when t is equal to 0, this will be the x-axis, this is the rho axis, this is 2. Okay, the solution is going to be 4 for this part up till 0. It's going to be equal to 2 for x not greater than 2. Again, this for x greater than 2. And then the blue part is actually just the linear interpolation between the two. This is what happens when t is equal to 2. Sorry, t is equal to 0. Now let's look to see what happens when t is equal to 1/2. So I'm going to draw my, I call this rho axis, but our variable here is u. Okay. So now this is what's going to happen when t is equal to 1/2. Okay, if I come back here to my formula, so if t is equal to 1/2, 4t is equal to 2. And then if I plug in t right there, it's going to be 2 times 1/2. 2 times 1/2 is 1 plus 2 is 3. So this is going to be 3. So I know the solution will be equal to 4 here. It's going to be equal to 2 here. And then it's going to be the linear interpolation between. And see what's happened, where the shock is that this blue part is not expanding, it's compressing. Because what's happening? The distance between the orange and the blue part here, that's a distance of 2, but the distance between the orange and blue part here is just equal to 1. And then finally, when t is equal to 1, let's see what happens. When t is equal to 1, well, 4t is equal to 4. So it's going to be orange from here to 4t. But then 2t plus 2, if t is equal to 1, that's also going to be 4. So it's going to be like this. Okay, and then now the linear interpolation part is just going to be a vertical line like this. So when x is equal to 4t, so this is going to be t is equal to 1. And when x is equal to 4t, we have this sort of like infinitely, well, it's sort of a triple valued size infinite value thing here. Okay, and it's going to be all of the values between 2 and 4. And then what's going to happen if we kind of keep looking at the solution, like if we keep using the formula, if we just don't do any more analysis but just keep using the formula that we have, we're going to end up with something like this. If this is going to be t is greater than 1, the orange solution is going to go to here, let's say, and the purple solution is going to be like this, and then the blue part is going to be the linear interpolation between those. Okay, so now clearly when t is greater than 1, our formula doesn't work. And so what's happening is the orange characteristics, like the orange solution is colliding with the purple solution. In terms of characteristics, the orange characteristics are colliding with the purple characteristics, so there's going to be a shock wave. But the shock wave is only going to happen when t is greater than 1. Okay, the other thing to consider is that if I look at my formula for the solution, if I look at the formula for the solution right here, if I look at this part, when t is equal to 1, this goes away. Well, what do I mean by that? Well, pictorially, it's happening down here. The distance over which the blue solution exists is going to 0. And finally, when t is equal to 1, it's 4 less than x less than 4. Okay, so when t is equal to 1, the blue part goes away. So the important conclusion here, after t is greater than or equal to 1, only the u equals 4 and u equals 2 solution remains. Only those solutions remain. So in other words, once we get up above, so this line right here is t is equal to 1. Once we get in this area here, I'm going to have to find the shock weight, but I only have the orange and the purple characteristics. So I only have the part of the solution where u is equal to 4 to the left of the shock and u is equal to 2 to the right of the shock. So the shock is going to start here because that's where they intersect, and it's going to go up like that. As we will see, it's going to be a line. The orange characteristics will come from the left, and the blue characteristics will come from the right. So let's now compute the shock. So the shock velocity, remember, it's going to be the jump in q across the characteristic over the jump in u across the characteristic. If I come back up here to my PDE, what is q? Well, I need to write the equation in conservative form. So to figure out what q is, I need to write it as partial tu plus partial x q of u is equal to 0. Well, remember, by the product rule, this is, or the chain rule, plus q prime of u partial xu. So in other words, this says that u is equal to q prime of u, the differentiation being with respect to the variable u here. So then q of u is equal to u squared over 2. Okay, so let's come down here. So to the right of the shock, the solution is 2. To the left of the shock, the solution is 4. So this is going to be equal to 1/2 ur squared, that's u to the right of the shock, minus ul squared, and then at the bottom it's going to be ur minus ul. Now the top is a difference of squares, so overall this becomes u right plus u left. Okay, and so I'm going to have this is going to be equal to 1/2 u right, u to the right of the shock is 2, u to the left of the shock is 4, and so this is equal to 3. So xs of t, so remember the s here means shock, this is going to be equal to 3t plus some constant. Now I know that it first hits the shock, so I know that the breaking time, that is where the characteristics first intersect, is when t is equal to 1. Okay, if I come back up here, they intersect when t is equal to 1, and that happens when x is equal to 4. So I know that, so I need to find that, I'm saying that because I want to find c. So I know that 4 is equal to 3 times 1 plus c, so c is equal to 1. So this is equal to 3t This is equal to 3t. Oh boy, well, great. Okay, so sorry, things are messing up. So this is going to be equal to 3t plus 1. So my pen has stopped working and I can't write anymore. So that's going to be the solution. That's going to be what happens. That's the solution. Xs of t is going to be equal to 3t plus c. All right, so here I am. Again, c is equal to 1. So this is equal to 3t plus 1. And so what this says that the solution, this is going to be for t greater than or equal to 1, u of xt. This says that for t is greater than or equal to 1, the solution is going to be u of xt is going to be equal to 4 when x is less than 3t plus 1. About to see a furry friend come into the shot here. And it's going to be equal to 2 when x is greater than 3t plus 1. Sorry. Okay, so let's look at a little bit more about these characteristics. So at the shock. So what's happening down here, this is the line right here. This is t is equal to 1. I'm not going to draw through it because it's going to you're not going to see what I want you to see. So this is the line t is equal to 1. This line right here, we see all of the characteristics are meeting there. And then after that, this red line right here is the shock wave. And I've drawn it so that you have the orange characteristics entering it from the left side and the purple characteristics entering it from the right side. And so we can kind of put all of the solutions together and say u of xt is going to be equal to 4. I forget what it is now. X is less than or equal to 4t. Whoops. X is less than or equal to 4t, and t is less than or equal to 1. It's going to be x minus 4t over 1 minus t. Then it's going to be equal to 2 here, and that is x 2t plus 2. This will be x greater than or equal to 2t plus 2. Here we're going to have 4t less than x less than 2t plus 2. And all of these are also going to be t less than or equal to 1, t less than or equal to 1. Then it'll be equal to 4 when x is less than 3t plus 1. And t is greater than or equal to 1, and then 2 when x is greater than 3t plus 1, and t is greater than or equal to 1. Okay. Let me just make these greater than 1. Just so that it's more definite. It's the same thing though. Okay. So this, oh no. Okay, so this is kind of the whole big solution. But again, the big thing here, the big sort of interesting thing here is that we have to split it between t is less than or equal to 1 and t is greater than or equal to 1. Less than or equal to 1, there's no characteristics. Greater than or equal to 1, less than or equal to 1, there's no shock waves, no intersecting characteristics. That happens after it's greater than or equal to 1. And then we sort of have this graphical analysis to sort of explain what's going on, and it indicates that we forget about the blue part, we forget about the linear interpolation part at the shock wave or after t is equal to 1, and so we just have 4 to the left and 2 to the right. Okay, that's it for this video.